The area of a healing wound is given by A equals pi r squared. The radius is decreasing at the rate of 3 millimeters per day at the moment when r equals 49. Big wound. Well, I guess it is in millimeters. Maybe that's not so bad. How fast is the area decreasing at that moment? Select an answer, millimeters per day, square millimeter. Oh, okay, so on screen, this looks more like a drop-down box probably. So you're looking for first the measure of the measurement here. So millimeters per day, millimeters squared per day, and square millimeters. Okay, that's probably it. All right. So the idea here is when we check out the rate of change of the area with respect to time. So rate of change of area with respect to time, its unit of measure is going to be whatever our distance is, so millimeters squared, because that's how you do area per unit time. And we said, is this in days? Yeah, so per day. So millimeters squared per day. And maybe these are two different options in the list here. It doesn't come up very well for me on this method, but that's what you're looking for, square millimeters per day. Oh, you know what? Now that I'm thinking about it, this is probably one, and this is probably one. It's too bad they didn't at least put commas in there for me. That would have been nice. I think I got it there. Okay, so square millimeters per day, that's going to be the one. All right, let's answer the other part. So we have the area is given by pi r squared. Now, don't fall into the trap of just taking and saying dA or A prime equals 2 pi r, because that gives you the derivative with respect to the radius changing. We want the derivative with respect to time changing. So we differentiate implicitly and we say dA dt is going to be pi times this outer function r squared, which differentiates to 2r, times the inside function's derivative, which is dr dt. So it looks like we have dA dt equals 2 pi r dr dt. And now it's just a matter of plugging information in as we find it here. So the radius is decreasing at the rate of 3 millimeters per day. So we're saying there that the radius is changing -3 millimeters per day. And it's a negative because it's decreasing. So this would be 2 pi times whatever we have for r times -3 to start off with. And this is happening at the moment when r equals 49. So that just means we plug in 49 for r. And now we have an ability to solve for dA dt, for which I'll just use the calculator. So 2 pi times 49 times -3, and that gives me -923.63. Is that how many decimals? One decimal, okay. So approximately -923.6 square millimeters per day. Now, they probably have adjusted the answer to where you just give it a positive result, just to simplify, because students often mix up the concept of this needing to be negative because the size is decreasing. But yeah, try the negative. If it works, great. Otherwise, switch and do the positive, because I think that's how they have the answer.